All right, future architects, let's talk. If you are deep in study mode for the ARE's PPD and PDD exams, you know that every single detail can make a difference. Today, we're going to zero in on a component that I promise you punches way above its weight class, the humble purlin. If you can master this, you're really mastering a key piece of the entire structural puzzle.
You've seen this a million times, right? Look at any big metal warehouse or a long-span building. See those horizontal members running across the main rafters? Yep, those are purlins. They look pretty simple, but here's the trick. The ARE wants to know if you can understand them from two totally different angles, and that's exactly what we're going to break down today.
So here's our game plan. First, we're going to nail down what a purlin actually is. Then, we'll look at it through what I call the two lenses framework, the PPL, big picture view, and the PD, in the weeds details view. After that, we'll run through the most common exam traps to watch out for, and then we'll wrap it all up with a quick lightning round of practice questions just to make sure all this stuff really sticks.
Okay, let's dive in. Before we even think about exam strategy, we have to build a rock-solid foundation. What is a purlin, and what is its fundamental job in a roof system? Okay, the key thing to burn into your memory is that purlins are secondary members. They run horizontally, so they're parallel to the eaves of the roof. Their whole job is to take all the load from the roof deck, snow, wind, the self-weight of the materials, and hand it off to the big guys, the main rafters or trusses.
I absolutely love this analogy. Purlins are the middlemen. They're the critical link between the roof surface, which is kind of like the tertiary element, and the primary structural frame. Without them, you'd be forced to use a ton of heavy rafters spaced really close together, and that gets super expensive fast. Purlins let you space out that main frame, which saves a ton of material and, you guessed it, money.
And here we go, trap number one. This is a classic exam mix-up, so listen close. Purlins are for the roof, girts are for the wall. They do a very similar job. They're both secondary framing, but if you call a girt a purlin on the exam, that's a red flag that you've missed a really basic concept. So say it with me. Roof equals purlin. Wall equals girt. Got it? Good.
All right, time to put on our PPD glasses. Remember, project planning and design is all about the why. It's about looking at systems, thinking about efficiency, and making those smart, high-level decisions early on.
So for PPD, you're not in the weeds detailing a connection. You're up at 30,000 feet asking these kinds of questions. Why would we even choose purlins here? Well, it's about economy. How does the spacing affect the cost? If you space them tighter, you might get away with a thinner roof deck, but then you're buying more purlins. It's a trade-off. It's a balancing act. This is classic PPD thinking, evaluating whole systems to find the best overall solution. This chart right here just nails the heart of the purlin mindset. For a huge, wide-span building like a warehouse, creating a forest of closely spaced rafters is just way too expensive. The smarter, more cost-effective solution is almost always to use fewer but stronger trusses spaced far apart and then let the purlins span between them. This is the core economic reason for a purlin system.
Okay, let's swap those lenses out. Welcome to PDD, Project Development and Documentation. Now, the why has already been decided. Your job is all about the how. How does this thing actually go together correctly, safely, and, so it doesn't leak? This slide, right here, this is your Rosetta Stone for this topic. In PPD, you're talking about economical systems and spacing. But in PDD, you're focused on fastening and deflection. See that shift? PPD is about the concept, PDD is about the execution. The ARE is absolutely going to test you on both, and you have to know which hat you're supposed to be wearing.
And in the PD world, the type of purlin you choose matters a lot. C and Z shapes are both really common, but the Z-purlin has a superpower. Because of its shape, one Z-purlin can nest or lap right over the next one at the support. And trust me, this is a huge deal.
And this is that superpower in action. By lapping Z-purlins over a support, you make them act like one long, continuous beam, instead of a bunch of separate, simple ones. That continuity makes them way stronger and stiffer, which often means you can use a lighter gauge purlin or span it further. That's a critical PDD detail the exam loves to test.
And speaking of stiffness, welcome to the world of serviceability. See, in PDD, it's not just about strength, it's about performance. Is the roof going to feel bouncy when someone walks on it? Is it going to sag and create puddles of water?
L over 240 is a super common deflection limit for roofs. And a lot of the time, this number, which is all about controlling sag, is what will actually govern your purlin selection, not just its ultimate strength.
All right, let's pivot to some quick hit exam traps, because sometimes knowing what not to do is just as valuable as knowing what to do, especially on exam day. Okay, this stuff is pure gold. First, those long, thin steel purlins, they love to twist or roll over when you put a load on them. You must specify bridging to stop that. Second, wind uplift is not the same everywhere on a roof. It's way stronger at the corners and edges, so you have to call for more fasteners there. Third, that steel purlin is a thermal bridge, a high way for heat to escape, cutting right through your insulation. And finally, please make sure your purlin spacing actually works with the width of your roof panels. These are all classic PDD trip-ups.
So here it is. Here's your mental shortcut for the exam. The second you see the word purlin, I want your brain to fire off this chain. Purlin is for the roof. Its special trick is the Z-lap connection, and you must always pay special attention to the edge zones for wind. This simple hook connects all the biggest ideas we've just covered.
Okay, theory is great, but let's put it into practice. I'm going to throw 2 questions at you, one PD style and one PDD style. Ready?
Okay, think like a project manager. The key words here are cost-effectively and corners. You've got a high wind uplift problem, but it's only in very specific areas. What's the smartest, most economical move you can make?
And there you have it. The PPD answer is never make the entire roof stronger. It's a targeted, efficient, surgical solution. You add strength only where the code, like ASC 7, tells you that you need it most. You save the client money by not over-designing the 80% of the roof that doesn't need it. That is peak PPD thinking.
Okay, now switch hats. Put on your detailer's hat. This isn't about cost anymore, it's about structural stability. You've got these long, kind of floppy purlins. What specific instruction has to be on your drawings to make sure they don't fail by twisting?
Perfect. This is a PDD answer through and through because it's specific and it's actionable. It calls out a specific component, the strap bridging, and it references standards, the manufacturer's requirements for the screw pattern. This is the level of detail your construction documents need.
And one last little tip. Don't freak out if you have to do a quick sanity check calculation. This simple beam formula, moment equals WL squared over 8, is your absolute best friend for getting a rough idea of the bending in a simple span purlin. It's the go-to for a quick check.
And really, that's the big takeaway today. This whole 2 lenses approach doesn't just work for purlins. Think about it for window flashing or control joints, or even something as simple as door hardware. The REE wants to know, can you think about these things conceptually for PPD? And then can you zoom all the way in to the critical nitty-gritty details for PPD? If you can apply this method to your other studies, you'll be in great shape. All right, good luck out there.